Just like any other component, servo motors have expert use and applications in different industries. For instance, if you dive into robotics, you might have seen its use in different parts of robots like arms, elbows, grippers, etc. If you look at the circuits of the creation of energy like solar panels, you will find servos there to adjust the angle. On the industrial side, you can see them in different grinding, bending, weaving machines. In the consumer sector, you may find them in cameras to adjust their lens. And, in our normal daily lives, the automatic doors are its biggest application in front of us. But these motors need a driver circuit to operate. So, together with us, let's understand servo motor driver circuit diagram. The above given servo motor driver circuit diagram is not much difficult to understand. To drive the motor, we first need the PWM pulses, and that's why we are using 555 timer IC, while the transistor is there in the circuit for the amplification of signals. For the output, we would connect the VCC wire at VCC, GND, with the ground and PWM wire at the collector side of the transistor. The wired NE 555 timer IC generates accurate oscillation and time delays. We connect switches at the trigger and threshold pins. So when we apply the voltage supply and press any switch, the IC gets triggers and the threshold pin compares the applied voltage with the reference voltage of 2/3 VCC. The value of the threshold depends on the resistors, capacitors. For example, if we press switch 1, the value would depend on R1, R2, and C1. When we press switch 2, the value would depend on R1, R3, and C1. Let's understand it more easily. The timer, which is working as an astable multivibrator, generates 2 or 3 kinds of pulses. When we press switch S1, the 555 generates a long duration high pulse, which high pulse time would be equal to 0.693, R1 plus R2, C1, and low pulse time would be 0.693, R2, C1. Thus, in this case, the servo moves in the right, that is clockwise direction. When we press switch S2, the IC generates a short duration high pulse, which high pulse time would be equal to 0.693, R1 plus R3, C1, and low pulse time would be 0.693, R3, C1. Thus, in this case, the servo moves in the left, that is anti-clockwise direction. I hope you have understood this circuit. For a detailed explanation, read the article, which link is in the description. For any queries, feel free to ask in the comments section. Also, do subscribe the channel for more circuit explanations and electronic engineering project ideas. And, click the bell icon to stay tuned.